Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To my panel, Dr. Evin, I hope you are in condition during this MCO. My name is Muhammad Tahfiz bin Muhammad SHARUDIN. Today I would like to present my undergraduate project titled 3D Topological Reconstruction of Point Cloud Mesh. This is the content of my study, comprises 5 phases, which is introduction, literature review, methodology, expected result, and lastly is the preliminary result. Introduction. So in this section, I will describe first about the background of my study. Modeling of the real object has become significant into the application. The real object can be modeled into various dimensional formats like 2D or 3D formats. There are many data type formats that can be used to represent the 3D object. One of it is point cloud data. Point cloud data can be described as a set of data points that consist of X, Y, and Z coordinates in space. This point cloud generally can be generated by using 3D scanners such as LiDAR or by using photogrammetry software that measures many points on the external surfaces of the object around. This point cloud can be rendered to produce 3D mesh. 3D mesh is the geometrical model that is processed from the point cloud data. It also is the surface representation with 3D points and connectivity that generated from the calculation of point cloud by sampling and computing a set of vertices and defining faces between them. There are many methods that can be used to generate the 3D mesh, such as the linear triangulations, alpha shapes, and ball pivoting. The main objective to generate the 3D model is to provide a better understanding in the scene, such as in development, in medical, or in augmented reality. However, this only involves the geometrical properties without involve the topological properties. Topology in spatial science can be described as a relationship between objects or features. It is one of the important information after the geometrical information. Topology also can be described as a mathematical methods that determines the spatial relationship between features by defining the connection between lines, identifying adjacent polygons, and also defines a polygon as a lines. And this is the example of, and in this table is the example of the topology for the object. So for zero-dimensional object, such as points, the topology for this point can be described as node. And for 1D object, such as lines, which is the connection between 2 points, the topology for these lines can be described as an edge or chains. And for 2D objects such as face or shapes, the topology for this object can be described as polygon, as a combination between lines. And for the 3D object such as volume, the topology for this volume can be described as polyhedron. And topology is essential in GIS as it is used for sophisticated analytic application and decision support tool. The operation for 3D objects in spatial operation, such as 3D navigation, is impossible for the 3D objects as it do not have the topological properties. Thus, in this study, we will implement the topological data structure for the 3D mesh data. This is the problem statement of my study. The first problem statement is 3D objects only comprises the geometric information without having topological. Thus, without having the topological information, it can hinder the ability for the spatial operation such as 3D navigation. Thus, this 3D object need to implement topological data structure on it to define its topological properties. The second problem statement is representation of 3D mesh in discrete form cause the initial 3D discrete model lost or unavailable. So this 3D mesh in discrete form need to be converted to continuous form by defining the adjacency and boundaries between this primitive. And the last problem statement is existing reconstruction still cause topology error, and this can limit post-processing of the 3D mesh, such as 3D printing. This error can be repaired by implementing topological data structure for 3D mesh. This is the research aim and objective. The aim for this research is to implement topological data structure for 3D mesh data that can be used to support custom 3D analysis such as adjacencies and connectivity. The objective of this study is to investigate the needs for reconstructing topological in 3D mesh. The second objective is to implement topological data structure to 3D mesh to support 3D spatial analysis. The last objective of this study is to evaluate the implemented 3D mesh with topological data structure. This is the research question of this study. The first research question of this study is to investigate what is the need for topological relationship in 3D mesh. The second research question is how to implement topological data structure on 3D mesh. And the last research question is to how to evaluate the 3D mesh implemented with the topological data structure. This is the scope of this study. The scope of this study is to developing a program computer that can implement a topological data structure for 3D mesh. This research also to study how the topological implementation can affect the visualization of 3D mesh and 3D analysis by testing the model. This study will use 3D mesh acquired for testing purposes. This study also will implement compact abstract slide complexes CICC topological data structure towards the 3D mesh. Literature review. The first literature review is about the 3D point cloud. 3D point cloud can be described as a set of points in 3D space produced from the 3D scanner to capture 3D representation of a scene. By having the high resolution and high density of the point clouds, it can produce a high accurate model of 3D objects. This 3D point cloud also have implemented in many industries as it can be immediately acquired from stereo vision cameras. And nowadays, with the advancement of technology such as in mobile, has made the point cloud to be extracted easily and cheaply. The next literature review is about the segmentation of the 3D point cloud. Segmentation of 3D point cloud can be described as a process to cluster point cloud with the same properties into homogeneous region. For instance, to cluster the point cloud in building classes, product class, water class, and others. By segmented the 3D point cloud, it can help for object recognition, such as object in meeting room consisting table, chair, window, wall, and others. Next is about the 3D mesh. 3D mesh is a surface reconstruction model that is generated from the calculation of point cloud by sampling and computing a set of vertices and defining faces between these points. There are many methods that can be used to generate the 3D mesh, such as Voronoi, Poisson, or by using the linear concepts. 3D mesh is also widely used in industry as it can provide a better scene interpretation compared to the point cloud data. Next is about the topology. The study of topological transformation and properties that are left invariant by the transformations. They also mean the topological aspect still remains same, although the geometrical is altered. In spatial science, it can be described as the relationship between spatial objects and basis for spatial operation. Without having the topological information, it can hinder the spatial operation of spatial objects such as 3D analysis, 3D navigation. Topological data structure used to describe the topological properties of spatial object. CICC topological data structure. The concept of the CICC topological data structure is CICC store topological information by using atomic cycle approach that through the 3D model elements. The cycle of atomic consider finish if the previous path of atomic cycles is navigated. This CICC cover from lower dimension of 3D model elements to higher dimension of 3D model elements. For example, for 0 dimension points to 1 dimension edge is connected by alpha 0 cycles. Next, for 1D edges to 2D faces is connected by the alpha 1 cycles. Next, for the 2D faces to form 3D volumes is connected by the alpha 2 cycles. And then 3D volume is combined by the alpha 3 cycles. This figure below show the alpha 0 cycle and its path. So based on this figure, for the first cycle of the alpha 0 cycle, the path for this cycle is from E01 to from E02 to E01. So this is the path. This is the path of the E01 to E to from E02 to E01. This also means the topology for these two elements. And this cycle will continue until it travels through all the elements of this 3D model. And the total for this alpha 0 cycles for this cubic is 24 cycles. Next is the alpha 1 cycles and its path. So based on this figure, the alpha 1 cycle, first cycle is from alpha 01 to alpha 02 to alpha 03 and to alpha 04. And based on this cubic, it shows that the alpha 01 is the lines of the connected points. So the path for the alpha 1 cycle is from alpha 01 to alpha 02 to alpha 03 to alpha 04. And then by combining this path, the topology of this the topology of this path can be described as phases. And this will continue until all the phases is described in this cubic. And next is the alpha 2 cycle and its path. For the alpha 2 cycles, the first alpha 2 cycle path is from the alpha 11, alpha 12, alpha 13, alpha 14, alpha 15, alpha 16. And by having the path between these phases, it can form the volume of the 3D model. Which is the volume indicates the topology of this model. And then for alpha 3 cycle and its path, it shows that the 3D it shows the connection between the 3D model volume. This is the related research for this study. The first related research is 3D model and topological analysis for emergency response in urban areas by Lee and Zlatanova in 2008. In this study, Lee and Zlatanova have developed a real-time emergency response system that implements network-based topology to support 3D analysis for emergency response. The implementation of 3D GIS in this emergency management system have enabled to decrease time for evacuation by creating the optimal route for the evacuation. So based on this figure, it shows that the shortest path route with the system can be found by integrating the floor map of this building with the GIS. The next related research is modeling and analyzing 3D buildings with primal and or dual data structure by Bogolowski in 2011. So in this study, Bogolowski have implemented a dual half-edge data structure as a topological model that can explicitly preserve connectivity information and support 3D analysis between building elements and its exterior. So based on two figures above, the shorter path inside the building and also the shortest path involved the building exterior can be found. The related research is 3D topological validation of compact abstract cell complexes data structure for building in CityGML by Saleh in 2020. In this study, Saleh and others have implemented CSCC topological data structure towards CityGML model for connected buildings and disjoint buildings. The implementation is to validate the CSCC topological data structure in CityGML model. The validation are by comparing the number of alpha 0 cycles and the adjacency metric values to validate the topology in this CityGML model. This is the result of their study. Figure above A and B show the adjacency metric value, and C show the alpha 0 cycle for each building. It shows that the value is same for both adjacency metric and number of alpha 0 cycle. Thus, the CSCC topological data structure can provide correct topology for building as the value for adjacency metric and number of alpha 0 cycle is same. Methodology. So this is the flowchart of my methodology approach, which is comprises 5 phases. The first phase is about the preliminary study. The second phase is data acquisition. The third phase is the program development. The fourth phase is program evaluation. The fifth phase is documentation. So in the first phase, the first phase the first phase of the study is to conduct preliminary study. The purpose of conducting a preliminary study is to identify the problems on why the 3D mesh need topology and how to solve it. In order to able to state the problems, reviewing on existing literature from various sources such as from books, journals, articles and websites are conducted. Besides that, when performing the literature review on the problems, the solution also can be found. Thus, this can provide the best output for the study to provide a 3D mesh with a proper topological information. Other than that, this phase also conducted to study the related research about implementing topological data structure onto the 3D objects. Next, the second phase is the data acquisition. So the data that will be used from in this study is the 3D point cloud data. So this data will be acquired from the image that captured on the study area. Next is program development. And in this program development, it consists 3 phases, which is program design, program coding, and program testing. So for the program design is conducted to design the user interface for the application. And then after finish with design the user interface, we will conduct the coding session. So the platform that will be used for develop the program is by using Microsoft.NET Visual Studio. And then the topological data structure that will be implemented in this study is complex data structure. And then after finish with development phase, we will conduct the program testing. The 3D mesh model that created will be used for program testing. And then we move to the program evaluation. The evaluation are carried out by identifying the spatial relationship properties for the tested 3D mesh. And then after finish with the evaluation, we will conduct the documentation. In documentation, we will record all the process involved, and then we also proceed to the thesis write-up. And this is the processing for the point cloud processing. The first process is to collect the images of the study area, and then after we acquire the images of the study area, we will generate the 3D point cloud by using eCapture 3D software. Then after acquire the 3D point cloud, we will segment the 3D point cloud to their corresponding classes object on the 3D point cloud. And then after we finish segmented the point cloud, we will conduct the 3D mesh reconstruction. Expected output. This is the expected output of this study. The expected output for this study is able to develop a program that can determine the topological relationship between 3D mesh. Based on the figure above, it shows the 3D mesh that generated from the 3D point cloud with semantic properties. However, in this image, the topological information is not included in the example. And then this is the preliminary result for this study. So I able to acquire the 3D point cloud based on the image collected, and this is the result. The process by using iCloud 3D and Gantt chart. Yeah, this is the process in this study, which is from the literature review, proposal writing, proposal defense, data collection, program design, program development, analysis, validation, documentation, thesis write-up, and presentation. So, according to this Gantt chart, now the progress of the study is on the data on data collection, as we are able to acquire the 3D point cloud data. That's all from me. Thank you.